Hi everybody, this is Mr. Raed Al-Nusayrat. Today inshallah we will have a lesson from grade 12 mathematics advanced stream term 1 lesson 3.3 computation of derivatives power rule. We have three learning objectives today. The first one is find the derivative of a function at a given point. The second one is sketch the graph of a function using the graph of its derivative. And the last one is use differentiation rules and higher derivatives in solving real-life problems. We have some keywords: derivative, higher order derivatives, instantaneous velocity, and instantaneous acceleration. We will start in this introduction. Let's first revisit the limit definition of derivative to compute a very simple derivative for any constant c, d by dx of c equal 0. So if I take the function f of x equal c, and from the definition of derivative using limit, which is f prime of x equal limit h goes to 0, f of x plus h minus f of x over h equal limit h goes to 0, f of x plus h. If I replace x plus h by x in the function is constant c, so the result is c. F of x also is c over h, so the final result is 0 over h, which give me 0. So the derivative of constant c equal 0. Now you have a question using the limit definition of derivative to compute the derivative of y equal x. You have 5 minutes to finish this task. Please make pause for your recording while you solve this question. After that, after you finish, back again to your record. Okay. Now we're back again. We will check together what is the correct answer for this question. F prime of x equal limit h goes to 0. F of x plus h now for the function y equal x will give me x plus h, because I will replace x plus h with x, minus f of x, which is x over h. Now I have translating here minus x with x. So it will give me limit h goes to 0 for h over h. Now h divided by h give me 1, so the final result is 1. That means for any constant c, the derivative is 0, and for y equal x, the derivative is 1. Theorem 3.1 power rule. For any integer n greater than 0, d by dx for x to the power n equal nx to the power n minus 1. That means the power is falling, and after that I will make a subtraction from n by 1, so it's n minus 1. So nx to the power n minus 1 is the derivative. Theorem 3.2 general power rule. For any real number here, not just for integer, for any real number, r not equal 0, except of 0, d by dx for x to the power r, it's r x to the power r minus 1. So it's the same rule. If I see here, it's the same rule I use. But here in the first one, the n is integer. Here, the power r is any real number. Now we will see this example. Find the derivative of each function. The first one, f of x equal x cubed. So f prime of x by theorem 3.1. 3, it's falling. So 3x to the power 3 minus 1. That means 3x to the power 2. What about g of t equal 2 to the power minus 4? So g prime of t, here I have a power as an integer minus 4. So it's minus 4 t to the power minus 4 minus 1. That means minus 4 t to the power minus 5. The last one, g of t equal 2 to the power 1.5. 1.5 is the real number, so theorem 3.2 tell me that g prime of t equal 1.5 t to the power 1.5 minus 1. That means 1.5 t to the power 0.5. In the next part, in next video, inshallah, we will learn how to prove these theorems. Now, what about general derivative rules? Here we have theorem 3.3. If f of x and g of x are differentiable at x, so f and g are differentiable, and c is any constant, then the first term is d by dx, derivative of x, for f of x plus or minus g of x, addition or subtraction between two differentiable functions. Here the derivative will be distributed, so f prime of x plus or minus g prime of x. What about the derivative for c f of x? C, it's a constant, so keep it here, and make the derivative for the function, which is f prime of x. Now we have example, find the derivative of each function. The first one, f of x equal x to the power 5 minus 4, so f prime of x equal 5x to the power 4 is the derivative for the first term, minus derivative of 4, it's 0. So the final result is 5x to the power 4. What about g of t equal t to the power minus 3 plus 2t? Here we have addition between two differentiable functions. So g prime of t equal derivative for t to the power minus 3, it's minus 3, t to the power minus 4. Why minus 4? Because minus 3 minus 1 give me minus 4. Plus, what about the derivative of 2t? The derivative is 2. Now, t to the power minus 4, I can write it in another form, like minus 3 over t to the power 4 plus 2, because x to the power negative n, as we know before, it's 1 over x to the power n. So don't forget this. Now you have a question here, find the derivative of each function. You have 5 minutes to solve these questions. Please make pause for your recording while you solve. After you finish, back again to your record. Okay, now we're back again to check the solutions together. So the first one is f of x equal to 3x to the power 4 minus pi squared. So f prime of x equal derivative for 3x to the power 4. 3 is constant. X to the power 4 derivative is 4x to the power 3. Minus, what about the derivative of pi squared? The derivative here is 0 because pi squared is a constant. Because pi is a constant, so pi squared is also a constant, so the derivative is 0. So the final result here, 3 times 4 is 12x cubed minus 0. It's equal 12x to the power 3. The second one, h of x equal x to the power minus 2 plus pi x. H prime of x equal derivative of x to the power minus 2, it's minus 2, x to the power negative 3, because minus 2 minus 1 is negative 3, plus pi times x. Pi is a constant, derivative of x is 1, so the final result is minus 2 over x cubed, because I take x to the power minus 3 to the denominator and change the sign of the power, plus pi times 1 is pi. Now we'll go to the higher order derivatives. Suppose we start with a function f and compute its derivative. Its derivative, it's f prime. We can then compute the derivative of f prime. If you make a derivative for f prime, that will be called the second derivative of f, and we write it as f to the power double prime, f double prime. Also, we can compute the derivative of f double prime, called the third derivative of f, which is written as f triple prime. We can continue to take derivatives indefinitely. Now we have a question here, example, compute the first 3 derivatives of f of x. So I will start from f prime of x. F prime of x equal derivative of 5x cubed, it's 15x to the power 2, because 3 times 5 is 15, and 3 minus 1 as a power is 2. Minus 4x squared, 2 times 4 it's 8, x to the power 1. 2x, the derivative is 2, and the minus 1 derivative is 0 because it's a constant. Now, f double prime of x, 15x squared, give me 30x, minus 8x, the derivative is 8, and 2, the derivative is 0. When I go to the third derivative, f triple prime, I must make derivative for second derivative. So what's the derivative for 30x minus 8? It's 30 minus derivative of 8 is 0, so the final result is 30. Next, we show common notations for the first 5 derivatives of f, where we assume that y equal f of x. So I have a function y equal f of x, and I will talk about the first 5 derivatives of f. We use primes only for the first 3 derivatives. The first 3 derivatives, you can use primes, f prime, f double prime, f triple prime. But when you go to the fourth derivative, fifth derivative, that means for fourth and higher derivatives, we indicate the order of the derivative in parentheses. Parentheses, that means you will put the number of derivatives between brackets. We will see that. Be careful to distinguish these from exponents. That means if I have f to the power 4, it's different than f to the power 4 between brackets. Because in the left side here, f to the power 4, that means f times f times f times f, 4 times. Product for f 4 times. But f to the power 4 between 2 brackets, that means the derivative, the fourth derivative of f. So be careful about that. Now here we have a table for fifth derivatives, order 1, 2, 3, 4, 5. Prime notation, because we have function y equal f of x, so the first derivative is y prime equal f prime, y double prime, f double prime, y triple prime, f triple prime. Now, when I go to the order 4, the derivative number 4, I cannot use primes, so I will use a derivative in parentheses between brackets, y to the power 4 between 2 brackets. That means the fourth derivative of y, and I can write it as f to the power 4 between 2 brackets. Also the fifth derivative. Now, what about Leibniz notation? Leibniz notation, we write the first derivative as df by dx, and I can write it as dy by dx because the function f, I named it by y also. The second derivative is d square y over dx squared. The third derivative, it's the same. It's d cube y over dx cube, etc. When you go to the fifth derivative, that means d5y over dx to the power 5. Now we have example here. Find many or compute as many derivatives as possible for the function f of x equal to 3x to the power 4 minus 2x squared plus 1. The first derivative, f prime of x, it's 3 times 4, it's 12, x to the power 4 minus 1 is 3, minus derivative 2x squared, it's 4x, and plus 1 derivative is 0. The second derivative, f double prime of x equal 12 times 3, it's 36, x to the power 3 minus 1, it's 2, and derivative 4x, it's 4. The triple prime, f triple prime, it's 72x, and derivative for 4 is 0. Now, when I go to the fourth derivative, I must put between 2 brackets like this, so the derivative is 72. What about the fifth derivative of x, derivative of 72, it's 0. When you go to the sixth derivative also, it's 0. So here I can write f nth derivative for x equals 0 for all n greater than or equal 5, because the derivative equals 0 starting from the fifth derivative. One important application of the second derivative is acceleration. Acceleration is the second derivative application. So, which is the instantaneous rate of change of velocity. So, the acceleration is the instantaneous rate of change of velocity. As we know before, if I have h as a height, h of t, if I have derivative for the height or the distance, that means v of t. Now, if I have derivative for v of t for the velocity, that means a of t. So a of t, I can write it's also the second derivative of the height. So it's h double prime of t, or the first derivative of velocity. We have an example here. So the height of a skydiver, here we have the picture of skydiver in Dubai. The height of a skydiver t seconds after jumping from an airplane is given by f of t equals 640 minus 20t minus 16t square feet. Find the first branch is the instantaneous velocity at any time t. So the solving for the first branch, he asked about instantaneous velocity. He asked about v of t. V of t, as we knew before, it's the derivative of height. So derivative of f. Derivative of 640 is a constant, so it's 0 minus 20 because derivative of 20t is 20 minus 32t because derivative of 16t squared is 32t. That means v of t equal minus 20 minus 32t, and the unit of velocity is foot per second. What about branch B? He asked me about the acceleration and instantaneous acceleration, which is the derivative of v of t, or is the second derivative of f. So I must have the derivative for minus 20 minus 32. Minus 20 derivative is 0, and minus 32 give me minus 32. So the final result is negative 32, and the unit of acceleration is foot per second square. So this is an application for the second derivative, which is acceleration. Now we will go to sketch the graph of f from the graph of f prime. Here we have the graph on the slide. We have a graph of the function f prime. So this is the sketch of f prime, graph of f prime. From this, I want to graph or sketch the graph of f. Now, I must have some features to the function f from f prime. I will start from well. First of all, I can say here f prime of -2 and f prime of 0 and f prime of 2, all of these equal 0. So f prime of -2 equals 0. F prime of 0 equals 0, and f prime of 2 equals 0. What that means? That means the function f has a horizontal tangent on these points at x equal -2, at x equal 0, and at x equal 2. So f has a horizontal tangent at x equal -2, 0, and 2. Also, from graph of f prime, I can say that the derivative f prime is greater than 0 from -infinity up to -2. Because the graph of f prime is up of x. So if I have here number line, and I will take -2, 0, and 2, and here I talk about f. About f prime from -infinity minus infinity to -2 is up of x. Up of x, that means f prime is positive. F prime is positive, that means f is increasing because all tangent of f in this interval has a positive slope. And the function which have a positive slope, that means the function is increasing. From -2 to 0, f prime is down of x. That means f prime is negative. So f will be decreasing because all tangents of f on this interval will have a negative slope. From 0 to 2, f prime back again positive. So f is increasing, and from 2 to infinity, f prime is again less than 0, so f is decreasing. So from this I can memorize or I can talk about the graph of f. It's increasing before -2. After that, it's decreasing from -2 to 0. Then it will be increasing again from 0 to 2 and will be decreasing finally from 2 to infinity. Now we will see together what about the graph. First of all, f prime -2 is 0, so f has a horizontal tangent. Look here, -2, we have horizontal tangent. Also, at 0, we have also horizontal tangent. And at 2, also I have horizontal tangent. From -infinity up to -2, f is increasing, as I shown here in the number line. From -2 to 0, f will be decreasing. And from 0 to 2, f will be increasing. After that, from 2 to infinity, f will be decreasing. So this shape is suitable for the function f. Also, function f, it must be smooth here at these points, here and here and here, because the derivative is 0. So be careful about if you make it as a cusp or as a corner, it will be a mistake. You must make a smooth function here because the derivative is 0. Here we have recap for our lesson today about the derivative rules. F of x equals c, c is any constant, so f prime of x equals 0. F of x equals x, derivative f prime of x equals 1. F of x equals x to the power n in any real number, f prime of x is n, x to the power n minus 1. If we talk about addition or subtraction between two functions, differentiable functions, f prime of x equals g prime of x plus or minus h prime of x. Also, if f of x equals a, and a is a constant here, a is a constant. So f prime of x equals a g prime of x. If we talk about the nth derivative, the nth derivative of f, I can write by two notations. I can use the prime notations or the Leibniz notation. So these notations means that nth derivative. Also, we talk about the velocity and acceleration and height, h of t. V of t is h prime of t, and a of t is v prime of t, or the second derivative of h. Thank you very much. See you, inshallah, again in next video.